So as I was saying, there's a Wikipedia link to kerogen, and you might want to read about it. Okay, so again, kerogen is formed from the organic matter trapped in sediments. There's about 10 to the 16 tons of carbon trapped in kerogen, content of kerogen on Earth. This is 10,000 times more than the carbon contained in all living matter. Uh, when you heat kerogen, uh, upon heating, kerogen converts in part to liquid and petroleum and natural gas. Um, so, how does this heating happen? When kerogen is deposited in geological material, that is sedimentation, uh, subsequent sedimentation and progressive burial or overburden provides elevated pressure and temperature. So, as this due to tectonic plate motion, as these sedimentary rocks get buried, the pressure and temperature increases, and that's how this kerogen gets converted to petroleum and natural gas. All right, here are some numbers. So again, the total amount of kerogen on the planet is 10 to the power 16 tons. That's about 10,000 times the carbon content of all living matters. About 1% of that gets converted to coal. About no, actually 1,000% will get converted to coal, and 3 0.003%, that is 3 parts per million, will get converted to gas and oil. Okay, so those are the numbers, and this diagram shows you all of that. Okay, so uh, why do we use fossil fuels? Because they have high energy densities. That is, per pound, they have more energy than wood. So 3 to 5 times that of wood. And they're inexpensive. So to get oil, you just have to pump it up from the ground, and coal, you just have to dig it up. There's nothing else you have to do, pretty much. However, as we know, the use of fossil fuels cause global warming. Um, if you use wood, unlike fuels such as wood, which are carbon neutral, so to get more wood, you'll have to plant trees, and the trees trap carbon dioxide from the atmosphere. So if you keep using wood and you keep replanting trees, then that's a carbon neutral thing, and that would be fine. Except that the problem is, the reason we switch from wood to oil and gases because their um, oil and coal have 3 to 5 times the density. Again, carbon dioxide causes global warming, and that's the problem. Okay, so here's the basic reaction. This is the major component of natural gas. When you burn natural gas, burning means oxidizing. You produce carbon dioxide, water vapor, and energy, and this is what we are after. Okay, so you burn methane, you get 55.5 million joules per kg of energy. Million joules per kg of methane burned. Okay, so here's a nice graph. This shows you the energy density. Million joules of energy obtained per kg. Okay, so you burn wood, you get about 10 million joules of energy per kg of heat per kg. You burn ethanol, you get about 25 million joules. You burn coal, you get about 30 million joules. Crude oil has 40 million joules, diesel 45, natural gas 55 million joules. So now you see why we switch from wood to coal and oil. Yeah. Okay, where do we find oil? You find oil between two layers of impenetrable rock. It's found in porous rock. Sedimentary rock is porous. Remember it, the kerogen under pressure and higher temperatures turned into oil and gas. So where we find is in between two impenetrable layers inside porous rock, and the water, oil, and gas has been squeezed out of the rock. So typically oil and gas deposits are 500 million years old. 20 tons of organic matter produces about 1 liter of oil. Okay. So where are the oil deposits located? A typical oil deposit might, okay. Deposits are trapped under the ocean or because of continental drift under land. So they initially are formed in the oceans, and then because of continental drift, you can find oil deposits under land. So again, layers, oil deposit, oil and gas is found in a large, in a layer of very porous rock trapped between two layers of dense, impenetrable rock. Now here's the deal. If you have, so here's an oil uh, containing region, and it turns out only about 50% of this oil can be extracted. So even with our best techniques, only about 50% of the oil can be extracted. So there's a lot more oil in the rock itself, and only 50% can be extracted. So here are some oil first used as a fuel in the mid 1800s. Early production in Pennsylvania and Ontario. So here's a oil well in Pennsylvania, and here's an oil well 18 from 58 in Ontario, Canada. So here's the picture of a small oil pump. Here's a picture of a large oil pump and offshore oil platform. Okay, let's pause here.